Hello and welcome to this video on solving radical equations containing two radicals. So this is, we're going to be looking at a couple examples of equations in which there are two terms, either one on both sides or two on one side, two terms that have radical with an expression with a variable as the radicand, right? So two radical terms. And I'll be discussing the steps I'm going to be following to solve these types of equations, containing two radicals, and going through the examples with you. So let me begin. So my first example, I see one radical term on each side, right, making a total of two. And there's a cube root radical, right, cube root of m squared plus 4m plus 4 on the left side equals the cube root of 2m plus 7 on the right side. And the variable here is m. And as with any solving of an equation, I'm trying to figure out what can I replace m with to make this a true statement. Right, so off to the side, I'll put up the steps I'm going to be following. So the first step is already done for this example, but that is to isolate one of the radical terms. Right, get one of the radicals alone, just one. Right. Now both of these happen to be alone, right? So this cube root of m squared plus 4m plus 4, this is already on its own side. Same thing with this cube root over here. I have one other example after this where it's a little more complicated. We have to actually do something to get this first step done. But for right now, that's finished. And notice how that's very similar to the previous video I put up on solving equations containing one radical, where you first isolate the radical term. And then this second step is also the same as the second step when we were solving an equation with one radical term. So let's say I'm looking at this radical here. This is isolated. It has an index of 3, right, is a cube root. I'm gonna want to after I isolate the radical, I would like to undo it, basically get rid of the radical here. So what we're going to do is raise both sides to the index power. Right. And in order for us to remember, we have to remember what this does when I raise a nth root to an nth power. And again, I think I put this up last video. Remember, if you take an nth root of some number, right, as long as this is a real number, right, as long as this isn't like the square root of a negative, right, as long as this is real, right, so as long as that's real, and I take this nth root and raise it on the outside here to the nth power, basically the nth root and nth power undo one another, and I'm left with the radicand of just a. Right? So this is what we're going to be doing, right? We're going to be undoing our radical symbols, getting rid of them. And again, be careful, right? This only works, this is only a good property for when this base is a real number. So again, no square roots or even roots of negatives here. Alright, so let me do that to this equation. Now again, I don't like to mess with the original equation, so I'm going to leave the original equation the way it is and write it again. And do step 2 here. Alright, so raising both sides, right, this entire side here to the third power, right, the index of that radical that's alone. Same thing, raise this entire side to the third power. And the same thing will be happening on both of these sides here, right? Because notice it's a radical by itself equals another radical by itself, and they're both cube roots. And since they're both cube roots, and I'm raising them to the third power, the radical and the power basically undo one another, and I'm going to be left with the radicands on both sides. On the left, I'll have m squared plus 4m plus 4, and on the right side equals just the 2m plus 7. So for this example anyway, raising both sides to the third power got rid of all the radicals. But that doesn't always happen in these equations with two radicals. Okay, so I'm going to say for step 3, I'm not going to have to do it for this example, but you'll see the next example I will. If there's still a radical, so if there is still a radical term, which there is not here, there aren't any more radicals, no more roots. But if there is, then repeat steps 1 and 2. Right, where you isolate that radical term and then raise both sides, to the index of that radical. Okay, so I don't have that here. So let me and just keep this in your head. I'll pop this back up again later. But then the fourth part, the next step, once you've eliminated all the radicals, all right, once all the radicals are undone, like I have here, no more radicals, you're going to solve. It's going to be a polynomial. It should be a polynomial equation, a nice polynomial or even rational equation. Solve the resulting equation after you've eliminated all the radicals. And then the last step, which should be the last step in any equation solving, check your solutions. And do so in the way it originally looked, right? I'll say in the original equation. Right. See if you get a true statement. Alright, so let's do those steps here. Alright, so I got step 4. Again, 3 was repeat steps 1 and 2 if there was another radical. I'm not seeing that. So I'm going to solve. Now this is a quadratic equation, right? You see the degree 2 here. And the way we were, in a previous video a while back, the way we were solving these quadratic equations was to take everything to one side, get 0 on the other, put it in that standard form for a quadratic equation, right? So I'm going to take away the 2m and the 7 from this side, to take everything to the left. Why not? All right. So on the left side, I have m squared, then plus 2m, and then 4 minus 7 is negative 3, equals, and then the right side I got rid of everything, so there's 0 over there. And then we tried solving by factoring. Right, this can factor m squared plus 2m minus 3, and again, if you don't remember how to do this, please look up another video on factoring quadratic polynomials or factoring polynomials. I'm not going to get into all that again. This video is about solving equations with two radicals. So this m squared plus 2m minus 3 would factor to m plus 3 multiplied by the other factor of m minus 1. And again, you can double check by actually multiplying these two, FOIL, and you'd get m squared plus 2m minus 3 back. All right. And then I have what I'd like when I'm solving a quadratic equation by factoring. You have a product equal to 0. So then by that 0 product property, the only way a product of some numbers is going to be equal to 0 is if one of these factors is 0. So either m plus 3, that factor is 0, or the other factor, the m minus 1, that could be 0 too, and that would be a true statement. And then in solving each of these, we get possible solutions of m equals negative 3, right? I would just simply subtract 3 from both sides of that one. Or, adding 1 to both sides of this, m equals positive 1. Now don't circle them, right? Don't say they're solutions yet. We must check them. Right? You should always, when solving an equation, check your solutions back in the original statement. Alright, so I'm going to do that up here. Slide. So we have negative 3 or positive 1. So here's the original equation where I'm pointing. And let me bring this up. Let's do the last part where we are checking our solutions. So one of those possible solutions was not x, it was m equals negative 3. Right? Remember, negative 3 or positive 1. So I go through, replace all the m's with negative 3, and let's see if we get a true statement here. So that's the cube root of negative 3 squared plus 4 times negative 3 plus 4 on the left side equals the cube root of 2 times negative 3 plus 7 on the right. Now I'll simplify this out loud here. Negative 3 squared is positive 9. 4 times negative 3 is negative 12. 9 plus negative 12 would be negative 3. And then plus 4 would be positive 1. We have the cube root of positive 1 on the left. And on the right, this radicand, 2 times negative 3 is negative 6. Then plus 7 is positive 1. We get the cube root of positive 1 equals the cube root of positive 1, or just 1 equals 1. That is indeed a true statement. Alright, so back on my page here, I'm going to circle negative 3. That is a perfectly good solution. That does make my statement true. Let's do it again with m equals 1. Okay, so below that, we'll check m equals positive 1. And the left side, you have cube root. Alright, so we plug 1 in. We have the cube root of 1 squared plus 4 times 1 plus 4 on the left. On the right we have the cube root of 2 times 1 plus 7. Right. So again, the radicand, I'll just go through it and state it out loud. 1 squared is 1. 4 times 1 is 4. So 1 plus 4 is 5, and 5 plus 4 is 9. We have the cube root of positive 9 on the left. Now that's not a nice number. The square root of 9 is great, that's 3, but this is the cube root of 9, right? The 9 is not a perfect cube, so I'm just going to leave it like that. And on the right side I have the cube root of, the radicand is 2 times 1 is 2, plus 7 is 9. So we get indeed the same number on both sides. The cube root of 9 equals the cube root of 9. So yes, 1 is also a good solution. So I'll also circle that. Right, so negative 3 is good, positive 1 is good, and we have our solutions. Now you might see them in some books. They'll write out for an equation the solution set with the little curly braces, and inside those braces, inside this set, they state the numbers that make the equation true, that are solutions. So the number negative 3 is in there, comma, the number 1 is in there, and that's it, right? Close the set. So you might see a solution set written out for an equation, or just circle the solutions once you find that they are actually good solutions. Alright, but the key to take away from this is the steps that I followed. Alright, and I'm going to walk through them again, and we'll do the same exact steps for the next equation I solve. All right, the next example. So first, isolate one of the radical terms, right, one of them. Then we want to undo that radical, all right, by raising both sides to the index of the radical. All right, and that brings into play this property here. Then if, after you raise both sides to the index power, if there's still a radical term, you're going to repeat steps 1 and 2, right? So isolate the radical term that's left over, and then raise both sides to the index of that radical again, right? Then you should have, after step 3, after you repeat steps 1 and 2 enough, you should have an equation without radicals, like this one here, the quadratic here. Solve that resulting equation, and of course at the end, always with equations, check your solutions. You may come across some extraneous solutions where you get numbers that you think are solutions but don't actually work in the original problem. And the reason for that, the reason you might come across some extraneous solutions is because of step 2. When you raise both sides to a power in an equation, you might actually change the domain of the expressions in that equation, and that could cause you to find some solutions that don't actually work back in the original statement. All right, so let's keep that in mind. All right, so I'm going to go through the same 5 steps one more time in this next example. All right, my next example is solve the following equation, right, with these 2 radical terms. I have the square root of 2x plus 1 minus, and then the square root of x plus 4. See, there are 2 terms with a radical, 2 radical terms, and they're both on the left this time. It's not like the last one where there was one on the left and one on the right. And that's equal to 1. Alright, so the same steps. I'm going to pick one of these radicals, one of these radical terms. So let's say I choose this one here, the square root of 2x plus 1. I'm going to isolate that. Alright, so that means, if I want to get that alone, I need to get rid of this other radical term. Alright, so this is being subtracted right now, meaning to get rid of it, I need to add it. Right, so I add this square root of x plus 4 to both sides. Alright, so now on the left side, I have the square root of 2x plus 1 equals, on the right side I have 1 plus that other radical, right, the square root of x plus 4. Right, and none of this doesn't go with this. And don't put the 1 and the 4 together, right, because the 4 is inside a radical and the 1 is not. You cannot none of these are like. None of these can be combined. All right, so I have one term over here that's just a radical by itself, and then I have 2 terms here where one term is just a number, a constant, plus, and this other term is a radical. Great. So I've isolated one of the radical terms, right, step 1. Step 2 was, undo that radical, this one here. Get rid of this radical by raising both sides to the index power. This is a square root now, so to undo that I would raise both sides to the second power, right, to the 2, index of 2. Now be very careful. This side has 2 terms, right, this non-radical term plus this radical term. So I'm raising this whole, again, you're raising this whole side to the second power. And I've mentioned this before, do not distribute powers. This is not 1 squared plus the square root of x plus 4 squared. Don't put the power on each term. You cannot distribute powers over sums or differences. What this truly means is the following. It means, square this whole side. Take that side, 1 plus the square root of x plus 4, and multiply it by itself. So the quantity 1 plus the square root of x plus 4 times again the quantity 1 plus the square root of x plus 4. All right. and then we're going to do all sorts of distributing or foiling, if you will. Alright, so let's see what this next equation looks like after squaring both sides. The left side, you have where the property comes into play, right? We have the square root of something raised to the second power that undoes the square root. So I have simply the radicand, just 2x plus 1 on the left side equals, and this right side is where I'm going to do a lot of work. Alright, got a two-term expression multiplied by another two-term expression. So I need to do a lot of distributing. First let's pick this one here, this expression in the first set of parentheses, and distribute these terms to the other one. So 1 times 1, well, that's just 1, right? So I've got a term of 1 down here. The next term, I'll be taking 1 times, the positive square root of x plus 4. Well, 1 times anything is itself, so 1 times the square root of x plus 4 will be positive, square root of x plus 4. Right? So that's the next term. Alright, then the next term, I'm done with the 1. I distributed the 1 to these two. Now I'm going to distribute this. The next term in here is the square root of x plus 4. Distribute that. Now the square root of x plus 4 times 1, they're both positive, plus plus, right? Positive, positive. So the next term is going to be positive, and this, anything times 1 is itself. So the square root of x plus 4 times 1 is again the square root of x plus 4. And then finally, I'm going to take this square root of x plus 4 and multiply it by the square root of x plus 4 again. So this is that case where you'd have the square root being undone, right? When you take a square root and multiply it by itself, the square root squared, well, that's exactly what's happening here. This is the square root of x plus 4, times the square root of x plus 4. So that's actually the square root of x plus 4, to the second power. So the square root would be undone, and I'd be left with just, positive x plus 4. Right? Okay, that's the square root of x plus 4 times the square root of x plus 4. And they're both positive. They both have pluses in front of them, so it'd be positive. And I guess if you want to put parentheses around it, you can, but you don't need to because it's a positive here. Now, if it were a negative, I'd keep the parentheses so we could distribute the negative. All right, but right now it's okay. All right, and some things I'm noticing. All right, these two terms are like radicals, right? This is a radical 1 times the square root of x plus 4 plus this is another radical term, the square root of x plus 4. You see how they're both square roots, and they both have the same radicand. They both have the same index and the same radicand. So these are, remember, what they call like radicals. And I did a video prior to this, on adding and subtracting like radicals, right? Radical expressions. You can only combine radical terms when they are like radicals like this. And you just combine the coefficients. This would be 1 plus 1. All right, so if I simplify the sides, the left side is still 2x plus 1. The right side, see I got this term of 1. The only other term that 1 would go with is the plus 4, right? I got plus 4 over here. So 1 plus 4, that's 5 for the constant. I have this positive x, right? Plus x, I might as well put that. And then these two terms can be added together. Right? I have one apple plus another apple. That's 2 of these. That's 2 plus 2 of these square root of x plus 4s. Right, that's what you do when you're adding like radicals. I have 1 of it here plus 1 of it there, so I have 2 of it, right? All right, great. So now that the sides are totally simplified, all right, do you see how I isolated a radical? I raised both sides to the index of that radical. You see how now there's still a radical term left over? So what I'm going to do is isolate, I'm going to repeat steps 1 and 2 because there's still a radical. I'm going to take this radical term here, this 2 times the square root of x plus 4, I'm going to get that alone. All right. In order to do that, I would need to get rid of this 5 and this x, those terms. So let's do that. Push this up. So I get rid of, I'll write the subtraction here. I subtract x from both sides. I'm also going to get rid of that 5, right? Subtract 5 from both sides. Alright, so the left side, we now have, 2x minus x, or just x, plus 1 minus 5, that's minus 4, equals, and then the radical term over here, 2 times the square root of x plus 4. Now, if you don't like the, you could get rid of the 2 as well and divide everything by 2, right? Divide by 2, but that would put some fractions over here. You'd have x divided by 2 and then minus, 4. Now, 4 divided by 2 is nice. That's just 2. But I'm not going to do that for right now. All right, I'm just going to isolate the radical term, right, this product, and then go through the same steps I've been going through. So I've isolated the radical term, and everything else on the other side, and then again, I'm going to raise both sides, that entire side and this entire side, to the index of the radical, which is again 2. That's another square root. So square both sides. All right, and don't forget, now this side has multiple terms, this side has multiple factors. Don't forget what it means to square a side, right? To raise something to the second power. This side means take x minus 4 and multiply it by x minus 4 again, right? That's what it means to square. And then this side means, take 2 times the square root of x plus 4, oops, that's x plus 4, and multiply it by, again, 2 times the square root of x plus 4. All right. So it's a little different than this side, because this side there are two terms. This is one term times one term. All right, a little different, but you can rearrange that product and get a nice result. All right, so the left side, lots of foiling, right? Distribute the x, distribute the negative 4. You'd have x squared, right? X squared, then minus 4x, but then another minus 4x, right? So minus 8x. And then negative 4 times negative 4, then, plus 16. All right, so that's the left side. The right side, this is just one big product here. There's no, there aren't two, it's not a 2 term times a 2 term like the left side. It's 1 term times 1 term. So you can rearrange these factors. I got the 2 times the 2. I can put those next to each other and get 4 times, and then the square root of x plus 4 times the square root of x plus 4. Well, that's when you take one of those, a square root and square it, right? A square root of x plus 4 times the square root of x plus 4 would be just x plus 4. And notice I am putting that in parentheses here again, like I did earlier. But this time they're actually necessary because I'm multiplying by 4. I'm going to need to distribute this 4. We're taking 2 times 2, 4 times this whole thing, this whole radicand, the square root of x plus 4 times the square root of x plus 4 is the quantity x plus 4. Great. Alright, so I've repeated steps 1 and 2 twice here. Isolated the radicals, raised both sides to the index, and got rid of the radicals. Now look at this equation. No more radicals, no more roots. So we solve this. Alright, now in order to do that, I would have to, I'm going to start off by distributing this 4 over here, get rid of these parentheses, and you'll see it is a quadratic equation again. Alright, so we have x squared minus 8x plus 16 on the left equals 4 times x plus 16 on the right. And then, as I did with the quadratic equation in the first example, right, when I solve a quadratic, I'd like to start off by getting it in that standard form where, everything's on one side, 0 on the other. So I'll take everything to the left here. All right, let's take away 4x from both sides. Take away the 16. And we're getting a pretty nice looking quadratic equation here. The left side we have x squared minus 12x. And that's it, right? 16 minus 16 is 0 equals 0. So everything on one side, 0 on the other. And I would factor this, and both of these terms have a greatest common factor, a common factor of x, so I factor that out. And then the factor left over would be x minus 12. Okay, and I got this product equal to 0. A product is only equal to 0, right, using that zero product property. A product is only equal to 0 when one of the factors is 0. So either this factor of x equals 0, or this other factor of x minus 12 is equal to 0. And then solving both of these, we get two possible solutions. X equals 0 or x equals 12, right? I would just simply add 12 to both sides of that last equation. Okay, and don't forget, don't circle them yet. Don't put them in a solution set. We don't know if these are good. Don't forget to check these results back in the original equation, right? So I know that was a lot, and I think the hardest part is probably going to be this part here for most people. When you square this side with the 1 plus the square root, right? Remember, you do foiling, you do lots of distributing, right? You can't distribute powers. All right, so I'm going back to the original equation, right? And this is the original equation up here where my finger is. The square root of 2x plus 1 minus the square root of x plus 4 equals 1. And I'm going to check these two solutions, right? The 0, my possible solutions are 0 and 12. All right, so I'll do that on another page. So we're checking. First, x equals 0. All right, if x is 0, and this is the original statement here, we have the square root of 2 times 0 plus 1 minus the square root of 0 plus 4. Is this equal to 1? All right, the radicand in this radical, 2 times 0 is 0 plus 1 is 1, so it's the square root of 1 minus, and then 0 plus 4 is 4, and this is the square root of 4. Is this equal to 1? And don't forget, I've mentioned this in many videos now, when you see this radical symbol with an even root, right, square roots, fourth root, etc., you're being asked for the non-negative root. Right? I know that every positive real number has two square roots, two even roots, a positive one and a negative one. This symbol asks me for the non-negative one. So what's the non-negative square root of 1? That's just positive 1 minus, and what's the non-negative square root of 4? That's positive 2. So I have 1 minus 2. Is that equal to 1? Well, let's see. 1 minus 2 is negative 1. And I'm getting negative 1 equals 1. That is wrong. So my solution of 0 is one of those, what they call an extraneous solution. It's a solution I found, but doesn't actually work back in the way the statement originally was stated, right, back in the original equation. So I'm going to eliminate 0. The only other one left is 12. Now if this doesn't work, that means the equation has no solution whatsoever. So I'm hoping 12 works. All right. So let's go back, separate that, and check x equals 12. Alright, so we have the square root of 2 times 12 plus 1 minus the square root of 12 plus 4. Is this equal to 1? Alright, this first radicand, 2 times 12 is 24, plus 1 is 25, so I have the square root of 25, again the non-negative square root of 25, minus, and then the square root of 16. 12 plus 4 is 16. Alright, so the non-negative, the principal square root of 25 is 5, positive 5, minus, and then the principal square root of 16, the non-negative square root of 16 is positive 4. And is 5 minus 4 equal to 1? Yeah, that works. Great. So 12 is a valid solution to my equation. So going back here, I can put it in a circle. All right, 12 works back in my original statement, makes it a true statement. Or you could write out that the solution set is, simply the set with the number 12 in it. Okay, great. But the key to take away from all this is the steps, right? When you see an equation with two radicals like this, right, two radical terms, isolate one of them, raise both sides to the index, that'll get rid of one of the radicals. If there's still a radical left after that, just repeat, 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 right? Just isolate the radical that's left over and raise both sides to the index of that radical. Do it again, and once you've gotten rid of all the radicals, then you solve the resulting equation, whatever kind of polynomial equation it is. And then, as always, with any equation, check your solutions. Make sure it works back in the original statement. Wonderful. All right, and I like to say at the end of these videos too, do the best you can to try and learn the material on your own before you go looking for help. I find that when people take the time and effort to learn something on their own, they remember it better and remember it for longer and are more proud of themselves for it. So of course, read the material, read through the author's examples, perhaps even work out the solutions to an author's examples before you see how the author did it, and then compare your work with the author's and see if you can learn from some mistakes there. Obviously work on tons of exercises, practice problems, check for solutions to those if they're made available so you can see how you're doing and keep track of your progress. And don't just give up on a problem after one attempt. Very often in mathematics there are several approaches that'll work for any particular problem. So if after several attempts at a problem you're still not getting it or still not seeing how to do it, maybe you should read through the material again, maybe even a third time. Because if you've been working on some problems, there's a good chance you have a better idea as to what the author wants from you, what the author is asking of you. So when you go and read the material again, or even that third time, you'll have a better idea as to what to look out for while reading. Maybe you'll catch some things too that you didn't catch the first time around. That'll make working on the problems that much easier. Okay, but just read it more slowly, more deliberately. Take good notes. But if after that, if after several attempts at problems and several read-throughs of the material, you're still not getting how to do things, still not seeing how it's done, still not understanding, it's not a sign of weakness whatsoever to go looking for help. Ask for help. That is what other people are there for, to help you. So ask a teacher, a tutor, a friend, someone in your class who knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos online. There's tons of those too. Videos like this one, or plenty of other ones out there that are better than mine. I assure you they're out there and are easy to find. But just keep at it. Stay persistent. Keep practicing. Don't give up. And above all, and I think this is also the hardest thing to do, is believe in yourself. Stay positive through your struggles and failures, because it's if you can stay positive and have a positive mindset and a good belief in your own ability to work through struggles and work through failures, it's amazing the difference a little change in attitude can make in the learning experience. And it's in those times of struggle and in those times of failure that you can learn the most. If you just keep at it and keep looking at it and try to fix things and learn from your mistakes. Maybe even try to make a game out of things where your end goal is the end of the game, and maybe try to make some fun out of it. So stay persistent, keep practicing, stay positive, please, and don't give up. And I just know you'll get it. And thank you very much for watching.